Yeah, so I'm just going to take a minute to give you my breakdown of yesterday's problem. So they give us a random sample of 1,026 adults, and they ask them just one question, and then they give us a breakdown of the responses, but want us to focus on one response in particular. Makes some major changes, right? So I kind of want to lock in on the make some major changes a piece there, which is 39%. And they want me to do a couple things with that. Find a 95% confidence interval. So when they tell me that, I want to just automatically assume that they're going to want me to go through that confidence interval template that we usually use. I'm not going to use the template today because if this were an exam, you're not going to have the template. So we'll just try to do our best to remember the parts to that. And the first part is the same whether you're doing hypothesis test or confidence interval. It's to state that parameter of interest, right? And they basically give us the parameter of interest. If you look, find a 95% confidence interval for what? For proportion of all United States adults who would respond that way. So you can just copy it, right? You can just write down new P pen P equals true proportion of all U.S. adults who would respond. Right, and then just copy. You can copy it word for word. It's right there. They give it to you right there. Who would respond, make some major changes. Okay, so that's the very first thing that you're going to do. State that parameter of interest, P. That's what we're attempting to estimate. Then we want to look at our conditions for inference. Are they met? Well, it does say random sample, right? So remember your conditions for inference. SRS, it does say that they took a random sample. All right, that is stated. Normality. Well, we had 1,026 times 0.39. That's certainly going to be greater than or equal to 10. And 1,000, oops, I get my numbers right. 1,026 times 0.61, also greater than or equal to 10. Okay, and then 1,026 is, whoops, less than a tenth of all U.S. adults. Okay, so two things so far. Parameter of interest, state the conditions for inference, and now we can go to work, right? What I like to do, or I encourage students to do, is just write the formula. You have it right on your formula sheet. If a confidence interval is an estimate, right, plus or minus a critical value, which we use Z for proportions, times the standard error, standard deviation, that's P times 1 minus P. In fact, that would be P hat, right? That's all we have for proportions over N. So I'll just write the formula, and then we'll just let the calculator do the heavy lifting, right? So in the calculator, this is stat, and it's a test. That's what we've been doing for the last couple of months. This is a 1 proportion Z interval. It's not on my screen. I have to go look for it. There it is. It's letter A. So you can either just scroll to that. I think if you type the letter A, it'll jump to it. But I want the 1 proportion Z interval. I'm not doing a hypothesis test here. So what was X? They didn't really tell me, right? They said 39%. That's not X. It's 39% of 1,026. So that's 0.39 times 1,026. Okay, so your calculator is not going to be happy with that. You're going to get an error. If you tell your calculator that 400.14 people responded in such a way, it's not going to accept that. So you just got to round that to 400. And then we had 1,026 in our sample size. And we want 95% confidence, right? Yep. Okay, so 0.36 to 0.4197. So to me, that's the easy part, getting the interval. All right, the tough part here, give an interpretation. So my interpretation would be, we are 95% confident that P is contained in this interval. I wouldn't make it more complicated than that, but they're stretching me a little now. Then it says, and give an interpretation of the confidence level. What do I mean by confidence level? So when I say I'm 95% confident, what do I mean? That means if we took 100 of these polls, right? If we took 100 different samples of 1,026 people, did it 100 times, and got different point estimates every time. Maybe another time we do it, we get 38%. Another time we get 41%, right? We get all these different p-hats from all these different samples of 1,026, and every time we get it, we compute an interval around those different point estimates. 95% confidence means about 95 of those 100 intervals, okay? Or if we took many, many intervals, about 95% of those intervals would contain P. All right, that's it. There's some of this you're gonna have to commit to memory, and like a definition like that of confidence interval, something like a concept like R squared. You just got to commit those to memory and be ready to push those out. That's why I think the AP flashcards I put out to you are pretty good for some of those. Just ignore, well, you don't have to ignore them, but we'll eventually get to chi-squared and regression, linear regression t-test, but not on the exam. Then part B says, an advocate for leaving the system, as it is now commented, based on the poll, only 39% of adults in the sample responded that they want some major changes made to the system, while 41% said that they want only minor changes or no changes at all. Therefore, we should not change the system. Of course, an advocate of leaving the system alone would say that, right, and interpret it that way. I think I told you all about the pretty famous book, How to Lie with Statistics. People do this all the time, right? So, what he's saying is technically correct, yeah, but then, so here's another way to interpret it, right? 30% said make minor adjustments. 39% said make major changes. So that means 69% are in favor of some kind of change. 69%, right? That's a big, big time majority, compared to 11% that say leave the system the way it is now. So that's a simple way to answer it. I think the scoring rubric gives you a couple of ways that you could reply to that. Okay?